Welcome back to another episode of Dave Does Math from Home. This one is going to be very exciting. Today we're talking about exponents. This is section P2. Exponents are super fun. Some of the weirdnesses surrounding exponents are not extremely intuitive on their own, but we're going to talk about them and hopefully get them to make a lot of sense so that you can move forward with a very clear and thorough understanding of how and why exponents work. So we'll start with what exponents are. They're little numbers on top of bigger numbers. I say as I write a 2 with a 3 on top of it. Some would say that this number is bigger than this one. I meant the size of the symbol, not the value of the expression. So it's a number you put on top, and it means repeated multiplication. So 2 cubed means 2 times 2 times 2. 3 to the 5th means 3 times 3 times 3 times 3 times 3. And x to the n means x times x times x times x times x. However many n is, this is n times. So that's the basics. If you want to turn this into an actual number, it would be 8. And if you want to turn this, it's 3 to the 5th is 243, I think. I might be wrong about that. Double check that. So that is the simple introduction of what exponents mean. The interesting part of this is going to come from what we're going to do with the exponents. We're going to start combining these in what I think are pretty interesting ways and doing weird stuff with them that is not immediately intuitive. So I'm going to start with multiplying expressions together. So if this is 2 cubed, and it means 2 times 2 times 2, and 2 to the 5th is 2 times 2 times 2 times 2 times 2. The question then becomes, what happens if we take something like 2 cubed and multiply it by 2 to the 5th? We know that this piece is 2 times 2 times 2. And we know that this piece is 1, 2, 3, 4, 5. 5 more. So this is 3 2's and this is 5 2's. And if you look at how many 2's we have all together, I think you'll find that we have 8 2's. Which makes sense because 8 is 3 plus 5. So one of the, I think, most interesting parts about exponent is that they kind of bridge the gap between multiplication and addition. So here we have an expression where 2 things are being multiplied, and here we have an expression where 2 things are being added. And it works like that because of the magic of exponents. This is a property that I like to refer to as multiplication outside is addition inside. This is a property of logarithms, or sorry, this is a property of exponents. There's a couple like this. And if you pass this course and end up in pre-calculus, you'll eventually end up talking about properties of logarithms, and the properties of logarithms are similar, but sort of vaguely inverted. That's why I accidentally said logarithm when I was writing this. So we have this multiplication outside is addition inside business, and that'll help us transform 2 cubed times 2 to the 5th into 2 to the 8th. Only if we have the same base, though. So if you have something else like 3 to the 7th times 3 to the 9th. I don't know what either of these things are simplified, but I know that altogether you should get 3 to the 16th because that's 7 plus 9. And if you have x to the n times x to the q, you should get x to the n plus q. And again, this only works when the bases are the same. Here it works because we have a pair of 2's, here we have a pair of x's, here we have a pair of 3's. If you have different numbers here, like if you have 3 to the 7th times 2 to the 12th, I don't know what that is. We could maybe figure it out if we had a calculator and a lot of time, but 2 to the 12th is I think 4,000 and something. 3 to the 7th is probably big. I don't know, 1,800 maybe? No, it's got to be much bigger than 8. Yeah, it's a huge number. I don't know what it is. I don't really care what it is. If the bases don't match, you can't really do anything. If the bases do match and you're multiplying, then you get to add the exponents. The next sort of property we need to talk about is what happens when things are divided. No, I don't want to talk about division yet. I want to talk about No, I do want to talk about division. That's right. So let's talk about a similar-ish example. If we start with something like 2 to the 6th, and then we say it's divided by 2 cubed. What we have here on top is 2 times 2 times 2 times 2 times 2 times 2. And on the bottom, I have 2 times 2 times 2. And these three on the bottom will each cancel one of their counterparts on top, and it'll just leave me with 2 times 2 times 2, which is, sorry, sometimes I get too quick about writing my multiplication symbols and it looks like subtraction. This is all dots. What we have is 2 cubed, which again, hopefully makes sense because this is 2 to the 6 minus 3. So if multiplication outside is addition inside, then division outside, hopefully, stands to reason that that should end up being subtraction on the inside. Hopefully it's clear what I mean when I say outside and inside. Here I'm using outside because it's sort of like between the two. This is an exponential expression and this is an exponential expression, and the division sign is like outside of that. And here the subtraction is inside of the exponential expression. Maybe between would be a better word there. I don't know. I've always, in my head, I've always used this idea of outsideness and insideness. Hopefully that's clear. If it's not, ask me some questions about it in class. I will be happy to explain further. So with this property, we can do some stuff like x to the 7th over x squared. This should give us something like x to the 5th. And if we want to do 5 to the 13th over 5 to the 11th, that should give us 5 squared. And if we want to do something like 3 to the 4th over 3 to the 6th, that should give us 3 to the negative 2. Which is all fine and good, but now we have to address the question, what does it mean to raise something to the negative 2? If exponents are repeated multiplication, what does it mean to multiply 3 by itself -2 times? How does that make sense? Let's talk about what 3 to the -2 means. Let me erase all this so that I can talk about that. Let's start with a slightly different thing. Let's do 3 to the 1 over 3 cubed. We know because of properties of division that this should be, if we leave this in terms of exponents, this should be 3 to the -2. The good news for us is that these are small enough numbers, like 3 to the 4th and 3 to the 6th, they're getting pretty big. I don't know what those numbers are exactly. But 3 to the 1 and 3 cubed, these are reasonable numbers. I can do this. 3 to the 1 is just 3. 3 cubed is 27. This seems like a fraction that I should be able to simplify pretty readily. This looks like it should be 1/9. And 1/9, I think, is the same as 1 over 3 squared. So this is what a negative exponent means. 3 to the -2, that's the same as 1 over 3 to the 2. We can test this in other situations as well. We can look at what happens if I do, let's say, 2 squared times 2 to the -1. According to the properties we just learned, the answer here should be 2 to the 1, which is just 2. I know for a fact that this piece is 4. This piece could be a mystery for now. That's fine. We don't have to figure out what this is. But I know that the answer is 2. So whatever 2 to the -1 is, it has to be the number I can multiply by 4 to get 2. And the only number like that is 1/2. It's a terrible 2. So 2 to the -1 is 1/2. 3 to the -2 is 1 over 3 squared. Generally speaking, x to the -n is 1 over x to the n. Or if you have a negative that's already in the denominator, like if you have 1 over a to the -b, that's the same as a to the positive b. My suggestion to you is, I think a lot of students end up thinking about negative exponents means denominator or reciprocal. And I think when people think of denominators and reciprocals, they think of flipping things upside down and putting things in the denominator. The homework and the tests and quizzes that we're going to do in the next couple weeks are going to involve a lot of negative exponents that are already in the denominator. So I think maybe the better way to think about negative exponents is flip it into the other position. So if you have negative exponents that are by themselves or like on top of something, flip them into the denominator with a positive exponent. If you have negative exponents that are already in the denominator, flip them into the numerator with a positive exponent. That's how negative exponents work. If that's how negative exponents work, and we already have a pretty good idea of how positive exponents work, then the next question becomes, What if I have an exponent that isn't positive or negative? Let's see if we can engineer that sort of situation. Let's talk about 4 squared times 4 to the negative 2. According to the properties that we just talked about, this should be 4 to the 0. Or, if you want to think about it a different way, we could say that this is 4 squared times 1 over 4 squared, which would be, or 4 squared, yeah, you can think about it this way. You can think about it as 4 squared over 4 squared, and that would be also be 4 to the 0. Or we could just think about this in numbers. This is 16 times 1 over 16, or 16 over 16. And when we write it like this, I think it's pretty clear that you should get 1. The very interesting thing about this property is that that 4 didn't really matter. If I take x squared times x to the negative 2, I'm still going to get x to the 0, and it's still going to be x squared over x squared, which should just be 1, sorry, x to the 0. So, things to the 0 power equal 1. Doesn't matter what the thing, it does matter a little bit. X can't be 0 for this to happen. Anything else, any other number to the 0 power gives you 1. Because something to the 0 power is like having that thing squared times that thing to the negative 2. That'll give you that 0 when you add the things across the top. But when you do it as multiplication, you'll get a 1. Things to the 0 power are 1 unless those things are 0. 0 to the 0 power is a weird indeterminate. 0 to the 0 power is like dividing by 0. It just doesn't work. Don't try it. Anything else to the 0 power is 1, sort of universally. There's 2 more things about exponents that I want to talk about, but this video kind of feels long already, so I'm going to cut the video. We're going to make a part 2, so stay tuned for that.